Thank you for I'm honored to be here today. I'm Jeremy Bartley. I'm a program manager for ArcGIS Online and the ArcGIS API for JavaScript. And I'm super excited to show you WebGIS enhancements really for the web. So everything I'm going to talk about is all browser-based. The GIS as a community is rapidly advancing and getting smarter. There's a couple of things that are coming together. First, we have many different data sources, whether it's from Waze, LiDAR, drone imagery, all that data is coming in together. Then we have an increase in computing resources, and this is especially true on the web. The browsers are faster than ever before with direct access to the graphics card through WebGL. Then we also have GIS innovation. GIS innovation such as smart mapping, data exploration, 3D, all of them coming together to really form WebGIS, which allows you to build distributed applications. WebGIS simplifies working with all types of that data using web maps, scenes, and layers. We can take each of the layers of information, tabular information, big data, LiDAR, bring them together through a common language like a web map or a web scene, and then share that out through applications. So let's look at a few examples. First, let's focus on 3D visualization. You can build today applications that are interactive, performant, and data-driven. Here's an application for 1 million buildings in New York City. And as I hover over the map, I get quick interactivity highlighting the individual buildings. Each of these buildings has attribute information that I can, on the client side, filter out. So here we'll filter out all the buildings that are less than 500 feet tall. I can also focus on the annotated buildings, so we can use opacity to highlight certain ones, and select the individual ones with those nice callouts on top of the building, and so forth. We can also do data exploration in 3D. This is the Maldives, and we're going to look at the ecological marine units. As we turn those on, that's lots of measurements at different depths all the way to the ocean floor. And in the browser, I can interactively explore this data, look at it. It's full of attribute information, so as I touch one of the points, I get the temperature, salinity, many other pieces of oceanographic information. I can use the smart mapping tools that are part of the JavaScript API in 3D to explore this data. Here we're looking at salinity, centered at the average. I can move the color to map where I want the data to see an individual data value. I can also explore different themes. So instead of above and below, I can look at centered, high to low. Centered on allows me to look at an individual slice of information. So explore that salinity, see where it occurs throughout the water column. What's coming into the web scene viewer in December and the API next year is measurement tools in 3D. Interact with the buildings, objects, and grounds directly in the browser. So this is Palm Springs looking up towards San Jacinto. The measurement tool allows me, as I move my mouse, I know the constant line of elevation across the scene. I can go ahead and enter a point and measure up the direct horizontal and vertical distance from that point. It's not just working with that elevation information, but also with data. Like in this case, the coast of Israel, I've got LiDAR information, and I can touch an individual LiDAR point and measure all the way up the coast. And we can also work against 3D objects. I could measure this tree, or I could put a point on the ground and measure off into the buildings in the distance. Let's focus a little bit on 2D visualization. 2D visualization powered by smart mapping, Arcade, which is an Excel-like expression language for anybody to be able to create interesting visualizations, and how that's going to be enhanced with geometry access in the coming release. So here's a map of counties in the US. I'm mapping the crop acres, and I'm sizing them by just the number of acres. But that's not the best map because I want to normalize it by area. So I can go in and create an expression. And this expression will allow me to map the crop acres divided by the geodesic area of individual features to the square kilometers. Now I'll get a map that's normalized by area and gives a more true representation of the information. We can apply that to different scenarios. Like in this case, we're looking at North Korea and its distance in miles to major cities throughout the world. We look at this expression, we're going to take a fixed point, which is North Korea, an individual point, create a polyline, and measure the geodesic distance along that line. And then I can color in those individual cities. This is going to be pretty powerful to allow you to build pretty expressive applications that work directly with your data, not just your attributes, but also the geometry. And we'll be doing a lot more in the future. Let's talk about 2D maps and performance. It's an exciting time to be a web developer today. With the advent of WebGL and modern browsers, we can really take browsers to the next level. Let's take a look at an example of this. Here's a CSV of schools. We'll open this CSV in Excel, and once it loads up, we'll see that there's about 165,000 rows. Now, we can take this CSV and drag it directly onto the map. We can open that CSV in the browser, scan its attribute information, pull out the lat longs, and then draw them directly onto the screen. All 165,000 points drawn directly in the browser. I can zoom in, get smooth responsiveness, maintain a nice graphics rate, and work with those records individually. So this means, with the advent of faster browser technology, we can do different types of visualizations working with much, much larger data. Faster performance means new visualization patterns. If we look at this example of New York, this is a million building footprints in New York City. Each building footprint has the year that it was built, and then once drawn, we can change how we're representing those buildings. So in this case, we're going along year by year and seeing where are new buildings being created, or what year were they created, and then fading out the older ones that were created before. This is a pure browser-based application that really is going to be exciting to see what people can do with this. A couple of things to note here. This is a feature layer working directly with the feature service hosted in ArcGIS Online. This is an important point. This feature service means you only have to publish your data once, generate the service, and work directly with it and create applications. You don't need to pre-cache your data. You don't need to build vector tiles off of that data and then manage that on your own. You can publish it once and work with it however you'd like to visualize it. We can take it the next step and look at Waze data in the city of Los Angeles. Here, the time slider is moving minute by minute across multiple days. We see the daily pattern of traffic in Los Angeles, with the white dots being the individual Waze reported locations, the yellow dots being slowdowns, and the red dots being accidents. All of this is the power of WebGIS in 2017 and 2018 will allow you to create very interesting applications that work directly with very large data sets directly in the browser. So through 2017 and 2018, specifically on the browser-based applications, we'll be introducing a set of widgets, both the client-side coordinate widget, directions in 4X, full screen, scene viewer. We'll get that measurement technology that I showed you a little bit before. There's also a heat map. We'll improve the WebGL feature layer to work with feature collections and CSV layers. We'll start to introduce support for mobile on 3D and adding more operations to Arcade. Then in April, after the Developer Summit, we'll finish out and move out of beta out of our 4 full X feature layer. We'll take that technology and we'll also put it into our 3X feature layer. This means that if you've got an existing 3X application or you're using the portal or online, you'll be able to get the benefits of that fast technology while you migrate your applications to 4X. Introducing support for client-side projection. 4X will include the measurement widget as part of the API, and continued improvements on 3D mobile, web map reading and writing, and then bringing us into the UC of next year, where the API is completely WebGL-based. We'll have editing UX support, and we'll have full web map support.